All right, today we're going to tackle a concept that's pretty much the bedrock of data science, machine learning, and honestly, just making smart choices in everyday life. We are talking about probability. So let's jump right in.
Think about it for a second. We face this kind of question all the time. Should I take an umbrella today? Is this a good stock to invest in? What's the best move in this board game? Our world is just filled with uncertainty. So how on earth do we deal with it?
Well, the answer is simple, but it's also incredibly powerful. We use probability. It's the language we've developed to talk about chance, and it's the absolute best tool we have for managing and making sense of an uncertain world.
Okay, but before we can really put probability to work for us, we need to get a solid grip on what it actually is. So let's start with the absolute core idea. What are we really talking about when we say the odds?
At its heart, it's really simple. Probability is just a way to measure likelihood. You know, when you check the weather forecast and it says there's a chance of rain, that's literally probability in action. It's our way of putting a number on how uncertain we are about something.
And we measure it on this really straightforward scale from 0 to 1. 0 means an event is impossible. Like, no way, it's not happening. 1 means an event is a total certainty. Yep, it's definitely going to happen. So if that forecast says a 50% chance of rain, on our scale, that's a probability of 0.5, right smack in the middle.
Now here's where it gets interesting. We don't always get to that 0.5 number in the same way. It actually turns out there are a few different, let's call them flavors of probability, and each one is useful for different kinds of problems.
We can pretty much break them down into these three main types. You've got classical, empirical, and subjective. Each one is a totally different way of thinking about and figuring out the odds. So let's take a look at each one.
First up, we have classical probability. This is the one you probably learned about in school, and it's the simplest. It works perfectly in these neat, tidy situations where every single outcome has the exact same chance of happening.
And the classic example is, of course, tossing a fair coin, right? You've got two possible outcomes, heads or tails, and they are equally likely. So the probability of getting heads is just 1 out of 2, or 0.5. It's clean, simple, and all based on theory.
But what about situations that aren't so perfect and balanced? Well, for those, we need empirical probability. This type isn't based on theory at all. It's based on cold, hard data from what's happened in the past.
So if we pull up the historical weather data and see that, hey, over the last 100 days, it rained on 30 of them, we can figure out the empirical probability. Our best guess for rain tomorrow, based on that data, is 30 out of 100, which is 0.3. See, we're using past experience to make a prediction.
Now the third flavor is subjective probability, and this one's a little different. It's not based on equal chances or historical data, it's based on a person's belief, their expertise, or even their intuition.
A perfect example of this is a doctor looking at a patient's case. Based on all their years of experience, their deep knowledge of the situation, and their professional judgment, they might say something like, I think there's a 70% chance of a full recovery. That's still a probability, but it's one that's informed by expert opinion, not just a simple formula.
Okay, so we know what probability is, and we know its different types. Now let's get practical. How do we start combining probabilities to answer questions that are a little more complex? Well, for that, we need to open up our probability toolbox.
Now, the two most important tools in this whole toolbox are the addition rule and the multiplication rule. They help us combine probabilities. And the key is to listen for two tiny but crucial words, or and and. Let's start with the addition rule, which is all about figuring out the odds of one thing or another thing happening. Let's see it in action. Imagine you're playing a board game, you're right at the finish line, and you need to roll either a 2 or a 5 to win. Well, the probability of rolling a 2 is 1 out of 6, and the probability of rolling a 5 is also 1 out of 6. We just add them together. So 1/6 plus 1/6 gives us 2/6, which simplifies to a 1 in 3 chance of making that winning move.
Now, let's grab our AND tool, the multiplication rule. Let's say we want to know the odds of drawing 2 red cards in a row from a deck without putting the first card back. The chance of that first card being red is 26 out of 52. Easy enough. But, and here's the key part, since we didn't put that card back, there's now 1 less red card and 1 less card in the whole deck. So the chance for the second draw is now 25 out of 51. To find the probability of both of these things happening, we just multiply them, which gives us about a 24.5% chance. All right, let's talk about a really powerful idea,
Bayes Theorem. Now, don't get hung up on the formula for now. Let's just focus on the core concept, which is just stunningly simple. It's basically the art of changing your mind. It's a formal way to update what you believe when you get new information.
A perfect place we see this is in medical testing. You start with what's called a prior belief. Let's say the knowledge that a certain disease is really rare in the general population. Then you get new evidence, a positive test result. Bayes' theorem is what helps you combine that prior belief with how accurate the test is to calculate a new, much more informed probability. And this isn't just theory. This is the engine behind so much of modern AI and machine learning. It's how we get smarter with data, one piece of evidence at a time.
So, we've gone over the what, the why, and the how of probability. Let's zoom back out for a second and pull it all together. What's the big takeaway from all of this?
When it comes right down to it, probability isn't just about math problems with coins and dice. It's a way of thinking. It's a powerful framework that helps us reason about uncertainty, weigh the odds, and ultimately turn what feels like random chance into a much more informed choice.
And that really leaves us with one final question for you to think about. Whether it's a big career move, a financial decision, or even just trying to plan your weekend around the weather, what uncertainty in your own life could you look at a little more clearly now that you have these tools? I hope this has given you some new ways to think about the world. Thanks for joining me.